Hello EFR 513 students. Today we're going to be talking about exercise 14, creating and exporting graphs in R, and here's the key. So you have the main assignment and then you have the key in the Blackboard site. So we're just going to go through this assignment. This is just basic introduction to some graphs you might use, and in the end we're going to use it on the disaster data. We're going to do a box plot there. Uh, okay, so we're going to go into R, and for this assignment, we're going to be simulating our own data. So when you simulate your data, you're going to get different data than me, okay? So you can use a seed function, but that's fine. So here we're going to simulate a binomial with 100 observations, and the probabilities going to be 50%. Okay, so then we're going to simulate it in our normal distribution, random normal, and the mean is going to be 100, or mean is going to be 10, and standard deviation is going to be 1. Okay, so we can go ahead and you can just copy this out, and we can just block this and run this. And as you see, we've simulated the data. So now we have individual vectors here. So in number 2, I want you to put it into a data frame, and we're doing that right here. So it's going to be called data 1. So here's our data frame down below, and you can see we have gender, yes, no. For example, if this is from a questionnaire, a survey, and then we have the values C1 through C4, column 1 through column 4. And again, we have the binomial 0 1s for gender, and 0 1s for yes or no. Okay, so that's what we're doing for number 2. Then we'll go on to number 3. I'm saying just create a histogram of that. So that's hist C1. So we're just going to do it for column 1. And we'll go ahead and block that, run that. And as you can see to the right here, here's our histogram. Now that's just a quick histogram. Okay, so then for number 4, we're going to create a bar plot with gender. Okay, so we can go ahead and run number 4. And here's a bar plot. Okay, so in the first part of this problem, I asked for a table. Okay, so that's what's happening in here. We're just asking for a table. So if we just run table, we'll see down here it gives us a table of 0 and 1s. Okay, we'll go on number 5. And again, we asked for a table, and we're going to do another bar plot. And this time we're going to label some axes. Okay, so you can see we have the yes no title up there, and we have some color as well. Okay, the color came from here. There's different options. You'll have to look what colors you want your graphs as. Here's light blue. The main is the title, and then we have the Y-lab as well, frequencies. Okay, we'll go on to number 6. We're going to do a bar plot again. And here we're bar plotting gender. Last one we did yes, no. Here's the gender one. Okay. Now, there's a function called ggplot, graphics plot, in there, and in R, and you can do more advanced graphs. You can still do the simple ones in there, but it gives you some features to do more advanced graphs. And so we're going to go to the library, and we're going to run that. Now we can always write in our packages here in our library, we come down here and I have GG plot checked. Okay, there's some different things here as well. So here it is right here, ggplot2. Create elegant data visualizations using the grammar of graphics. So I already have that one checked. So I'm just going to run it here again. So I'm going to block that and run it. Okay, and it just tells me some information about it. Okay, so now we're going to go ahead and use that. Now, when we're using ggplot, sometimes it's advantageous to make our categorical variables as factors. So far our data here is data underscore 1. Now if we look at gender is the 0, 1 variable within data data underscore 1, right? That's what we call our data set up here when we created it. Now it's created as a data frame. So if I just look at the attributes for gender in there, you see that we come up as just null. Okay, attributes, not a factor, null. And so I'm going to run it as a factor. What you see here is I'm just doing data1 $gender, and I'm assigning that as a factor. Same thing. So that's taking the database and reassigning it as a factor. And I'll go ahead and run that. We don't really need it in this place, but I should just be aware of how to do this. And now if I run the attributes, I'll see it comes up down here as factor. Okay, so that's just giving you some more options in advanced graphing. Okay, so the next one, using ggplot, we're going to run a bar plot like we did up above. So we have the ggplot, we have our data1, and then it asks for an aesthetic, and it's abbreviated here as right here. So we're plotting x equals gender, and then it asks for geometry, genome, and you see the bar. So the geometry of the plot plus the type of plot is in the end here. So we're just asking for a bar plot. So we'll go ahead and run that. And as you see, it's similar. I didn't put any colors in it or anything, but it's similar to what we had up above. So you can just do simple plots, but the idea behind ggplot is your plots are going to get more advanced. Okay, so then we're going to go to number 10. So we're going to plot a bar plot of gender, and then if they said yes or no. Okay, so we have the ggplot. Here's their data set, and our x is going to be gender, and we're going to fill with the yes/no question, and then our geometry is going to be bar. We're going to give it a title. Okay, so I'm going to go ahead and run that. And you see, so here's an example of a more sophisticated ggplot where the fill in here, our major categories of our two bars are gender 0 and gender 1. Okay, but then we filled it with the yes/no question. So on the gender, the females, for example, answered more no's than yeses. Okay, so we can really do nice complex plots with ggplot. Okay, so this is an nice example of incorporating more into your graph. Okay, we're going to go on to number 11. This time we're asking you to save the plot. Okay, if you want to import it out, things like that. So we're going to save it as a JPEG. There's many different formats, PNG and things like that. So I say the format of the output file. Here's the name of the output file, right in here. And then I'm going to give the width and the height of the file. These are like in rasters or pixels or something of that. And that's very important for us because we want to might get more information in the plot. So then we're going to go ggplot. It's aesthetic. We're going to do gender. Then we're going to fill yes and no, and then gname, and then we're going to label it. So the same graph as above, but now we're going to save it as a JPEG. And then when we're done with that, we're going to turn the device off. So I'm going to go ahead and block that. I'm going to run that. Now you see down below it did it in RStudio. Okay, so I'm going to go to my file, and we'll look at the name gender, yes, no. Just got to find it here. It's right here, gender, yes, no. I'm going to go ahead and click on that, and then here's our graph. So that's a JPEG file, and it's very importable into a document. Okay, and I can control the X and Y axes and things like that, the title, if I would like to. Okay. All right, for number 12, we're going to go ahead and do another plot here. So, and we're going to save that, but we're going to do a histogram this time, and the histogram's for C1. So again, I'm on 12. So here's my JPEG. Again, I'm going to store it as a JPEG. I got my name of it. I've got my width, height, and then I have the graphs. Now I'm asking for 12 bins. I could ask for more or less, and then the color and things like that. Okay, and then I turn the device off. So I'm going to go ahead and block that, run that. Again, that gives me a graph, and it sends it to my directory. I'm my working directory, and this is data 1. See, and here it is right here. So there's my graph. Okay, very nice. And again, I can control many options in the graph depending on the style of the journal that you're going to submit it to. Okay, for number 13, I asked plot a scatter plot of C2 and C1, C2. So here's my thing, my genome, my geometry is a point graph. And then I'm going to plot X C1, Y C2. And then I'm going to ask for a smoothing function. And then I'm going to label the titles. So this time I'm not sending it to a file. So here it is right here. So depending on what your graph, and you can put a linear model graph and things inside the graph as well. But here's just a smoothing line within the graph. Okay, for number 14, I'm asking for a box plot. And I'm going to do a box plot with data 1. The aesthetic is gender. And I'm going to do it on C1. Okay, so you notice that I'm after gender. And right now we have 0 and 1 gender. And then I say what's the group is also gender, and the fill is gender. But the variable we're plotting, the value here is C1. So the genome is box plot, and then I have my labs. So I'm going to go ahead and run that. Now when I'm running a file, I'm just holding down Control and hitting Enter, the two sides of the keyboard. Okay, and as we see, we get a very nice graph out here with the box plot. The center line of a box plot is the median, and then we have the interquartile range, meaning the 25 to 50%, and then the 50 to 75%, and then we have the tails, and the tails go out as far as 1.5 times the interquartile range, and if it's farther than that, we have an outlier. So here we see it's gender 0 and 1. Now we could label different things on this as well. Okay, So now we're going to do a box plot. Okay. An additional plot on 15. We're going to say a box plot of C1 and gender and add a panel for yes and no. So we're going to also include a panel for yes and no. And we're going to save it this time. So same thing here. But now how we go ahead and save it? Here's our JPEG, right? And then our height and width and things like that. So I'll go ahead and run this whole thing. Now this won't show up in the graphic window because we're sending it to our file. And we look at our name, data1, C1 box plot, data1, C1 box plot. And there it is. We have the two panels. So we have the gender, and inside that we have the yes and no. So you can see how we're getting very high quality graphs from R that can be used in publications. Okay, on number 16, so we've learned how to do some nice graphs, a couple nice graphs, and now we want to apply it to one of our large data sets. So let's go ahead and plot the total value loss in the disaster. This is from exercise 13. So plot a box plot of the total value loss, TV LOSS, versus state code from the disaster data. Save it as a graph. Okay, so first thing I'm going to do is set my directory. Where is this data? And then I'm going to read the loan data, CSV. We saved that in the last assignment. And then I'm going to look at the data quickly. And for me, I always like to when I run this and I run the attributes, just to make sure what I'm looking at in my data, because sometimes you can miss what your columns are actually labeled. So for me, I always like to go get those columns and just paste them in here as a comment. So when I have this data set here called disaster, these are my column headings. Okay, so then now I'm ready to do this plot, and I'm going to call it total value loss box plot. I'm going to save it as a JPEG. Now notice here the width is going to be 1,000 and the height's 550. Okay, so then I go ahead, ggplot. This is my data, disaster, and my aesthetic is going to be state code versus TV loss, and I'm going to use group as state code and then fill as state code. And my geometry here, again, what type of graph is this? It's a box plot, and then I'm going to do a little labeling. So I'm going to go ahead and run this whole thing. And we get a little red down here. There were some missing values in the data set and such. So I might go investigate what that is or have cleaned that better. In this case, it's maybe not the most clean. So I'm not worrying about that. And so then I'm going to go find my file. And I look at what I call it, called data1 C1 box plot. Right here, data1 C1 box plot. Whoops, that's not it. Called it data1 C1 box plot. Oh, here, I'm on the wrong one. Hold on. Okay. Okay, so here's what I call TV loss box plot. TV loss box plot. Okay, so we see here, this is a very nice graph. As we see, Florida had some of the biggest losses. Okay, and right? There's a lot of outliers in this data. These are the business losses. So, but just very quickly, I see Florida had a lot, and California had some, and then I want to say that's MP had a lot. Okay, Ohio up here. So at a glance, I can see the losses of the disaster funding, the amount of loss assessed. Now notice this graph is longer than it is high. Okay, that's kind of very important. So with readability, so we're going to go back and run this, and we're going to change the width, for example, to 500. So let's change it to 550, so it's a square graph. And as I rerun that, and now look at the graph, you can see how it's scrunched down here. It's very difficult to read. Okay, so you have control over the height and width of your graph for readability and functionality, right? So that's a really important aspect of like the ggplot and what you're getting out of this. So I'm going to change this back to 1,000. So I'm just going to rerun that again. And as you see, here's it back to 1,000. It's much readable. I can read the numbers. It maybe could be a little shorter, but that's very functional and highly functional graph. If you just wanted to emphasize who had the most damage from natural disasters in the business world. Okay, and that's the assignment. That completes it. This gets us starting in graph. Of course, you can do a lot more, and can do a lot more, but this is just the beginning. So thank you so much.